Hi, let's calculate the possible key of the universe. We're looking at this study from the Royal Astronomical Society, which observed a very slow pressure wave emanating from the supermassive black hole at the center of the Perseus galaxy cluster. This pressure wave is incredibly slow, completing an oscillation once every 9.6 million years. For reference, this note in the middle of our keyboard, A, oscillates about 440 times per second. So in comparison, the Perseus galaxy is singing a very, very low note. As far as I know, it's the lowest naturally occurring note that we've found yet. So as any good bassist would do, we're gonna let this note be the fundamental of our chord that is the universe. But just how low is it? Well, let's find out. First, we need to convert years to seconds because pitch is generally measured in hertz. 1 hertz equaling 1 wave cycle per second. 9.6 million years roughly comes out to 302 trillion seconds and some change. Let's write that out in scientific notation just to be a bit cleaner. This number is our period of oscillation. Let's convert that to a frequency by taking its reciprocal. Now simply take this frequency and multiply it by 2 a metric fuck ton of times until you reach somewhere between 20 and 20,000 hertz, which is the range of frequencies that humans are generally able to perceive. And voila, the Perseus galaxy cluster sings a very, very low B flat or B half flat depending on what tuning system you apply the note to. We can do a quick cent calculation to see exactly how far we deviate from a 12-tone equally tempered B flat. And there you go, we are approximately 34-ish cents off. So it's actually probably more appropriate, albeit more confusing, to call this a B half flat instead of a B flat. Yay, microtonality. But just how low is this B half flat exactly? We need some sort of frame of reference to ground it and make some kind of sense out of it, right? We could just count the amount of times we doubled the initial frequency and compare that to a known quantity, but I think I know a way that might be just a little bit more fun. Take this formula for calculating the frequency of a given musical note, where F sub n is the frequency of the desired note, F sub 0 is the reference frequency, let's pick A440 for simplicity, and n is the number of semitones away from the reference note. We want to find which n corresponds to our frequency. So let's rearrange, plug in our values, compute the ratio, take the base 2 logarithm of this ratio, and finally solve for n. And we are 682 semitones, or about 56 octaves below A440. Damn, that's a bass note like I'll never hear again.